So officially now we can look at a way to determine if two ratios are equal, and it's through the equality of ratios. And we do it the same way that we check to see if two fractions are equal. So if we want to know if two ratios are equal, these two ratios, what you do is you cross multiply, and if A times D, right, is equal to B times C, then those ratios are equivalent, or we would again say that they are equal, or again, it's just like when we do a fraction. So here's another task here. How would we check to see if in this situation, right, would an orange mixture with a concentrate of 2 to 4 be the same as 1 to 3? And it's common for students to think those are the same ratios because they're 2 apart, right? 2 plus 2 is 4, 1 plus 2 is 3. But when we look at the test, is 2 to 4 the same as 1 to 3? Cross multiply, 3 times 2 is 6, 4 times 1 is 4. You get 6 does not equal 4. So those are not equivalent ratios using the equality of ratios test that we have there. And so we want to know, moving forward, why would we care about kind of this situation? Well, when we have ratios that are equal to each other, we can write it as a proportion. A proportion is a statement that two given ratios are equal. And then once we have that, we're allowed now to answer questions like this here. Here's another example. 3 cartons of chocolate milk for every 7 students at the school. If there are 581 students, how many chocolate would you need? So this happens in everyday life where we have to compare these values and have an estimate about how much do I need under this situation if I want to expand that out or decrease it. So in this case, what we do is you write them as ratios. 3 cartons to 7 students. How many cartons to 581 students? So you end up with this scenario here. And then we have to do a quick review of how do we solve a proportion, right? 2 ratios equal to each other. So we can predict what this value is here, right? The question mark. We can predict that because we're saying they're going to stay within the same ratio. And so we can make them equal. And how you solve that is through cross multiplying. And so in that case, what you end up doing is we end up multiplying, just like the equality of ratios. We cross multiply. You do your 581. And again, that comes from your equality of ratios. And I get 1743 is then equal to 7x. And then you just divide both sides by 7 in that case. And so you're going to need 249 cartons. Oops, not right. Cartons. And that's how you would solve a proportion problem. We'll look at some more of those. And on this problem, one thing that we were interested in that we actually have here is what's called rates. And it's how we apply these to these situations, right? Ratios involving units, right? Cartons students are called rates. And you'll see rates all over our daily life, right? As we look at, you make $12 per 1 hour, right? Something like that. How much money you make. You will see these rates pop up all over in our situation. Here's another task here to look at. And so you'll see here, solve the following scenario. Compare and contrast your methods with your peers here. And so here's the situation. 117 ounces for 6.5 weeks. At this rate, how many ounces of detergent is a year's supply? So I set this up 2 different ways, as you can see here. And as you look carefully here, you'll see one is you would write it as a proportion. 117 to 6.5 is how many ounces to 52 weeks. Cross multiply, you get your answer. Another way is to convert this to what we call a unit rate. 117 ounces to 6.5 weeks is 18 ounces per week. So then I just do 18 times 52.